Hello. If you remember from the last video, I completely forgot to record typing these, so I'm just going to quickly explain what I did back there. What I'm doing here is just creating the folder for the prefabs, and then I'm using the Unity's prefab utility functionality to create the prefab utility.create prefab, and you have to provide the path, which is going to be relative to the assets path, and I'm here providing assets minimap prefab and then the name of the texture. You don't have to provide the name of the texture. The reason I'm providing the name of the texture for all of these is because I want they all to have the same name, so you can identify them later after you save them in the asset bundle. So instead of going confusing, like where you have different names for individual objects, and you're gonna misloading them. So that's why I'm having assigning all the same name. So, and here I'm creating prefab, which is the function that we created in the last video, and which is a game object, and it's right here. What I'm doing here is creating a game object and adding a component, mesh filter and renderer, and rotating it to facing upwards. And then I'm setting the shared material. It doesn't really have to be shared material, since this material is unique to each prefab. In this case, and what I'm doing is I'm getting the mesh filter and sharing the share mesh. But in this case, because the mesh will be shared by multiple planes, so I'm setting the shared mesh to be the mesh that we got earlier. And then I'm getting the renderer, and I'm disabling shadows and receive shadows, also doing that. And that's I forgot to record those, so that's why I'm just quickly explaining what I did back there. And I'm refreshing the asset database, so the effect takes place instantly instead of you had to switch windows. Alright, now what we're going to do is we're going to create a couple more classes. Actually, we're going to create a function to actually load all of these. From now on, we definitely need Pro, because asset bundles are a Pro only feature. So from this moment on, you definitely need Unity Pro. But I will be offering alternative to load these planes in Unity 3. So I'm going to create a function to save all of these in asset bundle, including the settings file. So let's get started. I'm gonna do it in the same folder, same class. So private static void save selection. No, I don't want save selection to. No, let's call it a reasonable name. Map asset. All right. Now we're going to be coding these. So first, we need to make sure it's under the menu. So let's give it this attribute, menu item, same thing. It's going to be sitting under the same menu. Utils, export selection to map asset. I guess it's reasonable to export. All right. Now what we're going to do, we're going to get the selection as we did earlier. Same thing, selection dot get filtered, and this time we're going to get object or game object. You know what, since we will also need the settings file, let's say game object. Oh, my bad, object, and then we have to provide the selection mode, deep assets. And if selection is not null, now we're going to provide the save dialog box, and path. It's going to display in a save dialog box. Editor utility dot save file panel, and then you're going to give it a title, save asset, and then directory. I'm going to provide an empty string which will save the file to the current directory which we are on, and the default name, new data. I don't know, you can give whatever you want. In this case, I'm gonna save all of my data as dat file. That's how I do. You can save it as Unity3D or whatever you want, or you can create your own extension. And we're gonna make sure the path is not null. If the path is not null or empty, oh, that's right, false. Alright, if it's not null or empty, we're gonna save it. And then we're gonna get the assets, the settings assets manually. And then we're gonna say asset database dot load asset at path, and we're gonna give the path. So I'm assuming it's located under this directory. You can actually show another open panel and then have them pick what settings file they want. But in this case, I know what settings file and where it's located. So, and that's the settings file. It's gonna load, and we have to give the type, I believe, type of text asset, and make sure you cast it as a text asset. Alright, and then if the settings assets does not exist, if it's null, we're gonna let the user know debug.error settings file not found under Minimap folder, and then we're gonna return. And if it did find, what we're gonna do is we're gonna build the asset bundle. So this is how you build an asset bundle. We're gonna call build pipeline dot build asset bundle, and then you're gonna provide the main asset. In this case, the main asset is going to be the settings asset. Yeah, and then what we're gonna do is the selection, how many objects do you want. So the selection right here, selected objects, actually in this case selected prefabs, and then we're gonna give a path. Now we're gonna provide a bunch of flags. I'll explain what each flag does. First flag is going to be uncompressed asset bundle. In this case, we're going to be building this asset for Windows standalone. So Windows standalone requires uncompressed asset bundle, but if you're building it for a web player, you really don't need. You need compressed asset bundle. And then the second flag is going to be collect all dependencies. In this case, this prefab is going to depend on materials, mesh, and the texture. So we gotta collect all those dependencies before we build it. If you don't provide this flag and you build the asset bundle without collecting all the dependencies manually, you're gonna get error because you won't be able to see the texture, or I mean the prefab, when you build it. And then complete asset. This will get the complete asset, and this will build the actual asset to the path provided, and we're gonna show the user what assets that got built by selecting selection dot objects equal selection. This will select the objects and will let the user notify that these are the only assets that got built into the asset bundle. And let's build our asset bundle. So what I'm going to do is go back and let time to compile and make sure it came up in the menu. There it is. And go to prefabs folder, select all the prefabs, and go export selection to map. I'm going to be saving it. Oh, it looks like something went wrong. Did I give it a wrong value? Oh, that's true. You don't provide the asterisk. My bad. Okay. And give time to compile, and make sure you select them. Alright, so I'm going to be calling mine. I'm going to be saving it inside. You know what? Let's save it outside the asset folder. Let's save it map data.dat. Save, and give time to build everything. Alright, let's make sure it actually did build it. So I'm going to open it in Explorer. and oops, there it is. Map data dot dat. Depending on how much texture and how much quality you build it, the file size may increase. So in this case, the terrain is really small and the planes are less. Our file size is under 1 megabyte. Let's close that. And now what we're going to do is we're going to be building classes to actually load all these the planes that we just created. So the first class I'm going to create is MapSegment, which is going to hold the game object. After we load the segment, we're gonna assign it to a class, and then the game object is going to sit in that class, and it's going to have the state, whether it's creating or loading or destroyed, whatever. I'll explain as I create them. We're going to be closing these editor class we don't need at the moment, and I'm going to be creating a new class called MapSegment. Okay. It's going to be under a namespace. Let's call it my map, or my Minimap, I guess. Alright. Because this will be an external class, this will not be linked to Unity directly. We don't need any of those. Actually, we may need Unity Engine. Alright. And first object, of course, as I mentioned, game object. This will hold the plane, the actual prefab to the plane. And let's call it game object. I'm going to give a public getter and setter. And we're going to be creating another enum called segment state. It's going to hold this current state of the segment. So getter. Unfortunately, this does not exist, so I need to create it. Let's create another class called segment state, and it will also be under the same. You don't have to put it in a namespace, but I like keeping my classes under namespace if it's an external class. Oh, it should be an enum, and it will derive from byte. And first thing is going to be destroyed, and loading, and loaded. So actually, so this is the three states that the map's going to have, the segment's going to have, or make it active, I guess, because it's too close to loading. So just in case you. Alright, and oh, that's true, state. I didn't give a variable name. Alright, and then first method, we're going to create a couple of methods for this. Not if. Public void, able to destroy a segment, but it will not destroy the class. Don't worry, I'll explain everything when we get to the next part. If the game object is null, what this will do is destroy the current game object if the function is called. Okay, if the game object is not null, it's going to destroy. So we're going to call game object dot destroy, and we're going to provide the game object. And then we can actually, if the reset state was true, we're gonna set the state to destroyed, and we're gonna create another method, public void reset. This will reset the current segment. Only what it does is only gonna assign the game object to null, and then reset the state null, and this dot state equal segment state dot destroyed. This will reset the state, and another function void replace. This will replace the current segment, actually the game object, in the state of another segment, map segment. segment. If the current game object is not null, we're gonna destroy the current game object, because we don't want to be leaving any game objects undestroyed. This will consume memory and take up space. Okay, so this will destroy the current game object, and then move on to this dot game object equal segment dot game object, and this dot state equal segment dot state. All right, those are the three functions. Don't worry, you don't really need to know what they do, but as we code along for the next class, you will understand what all these does. And let's create that class. This class will handle the map. We're depending on the player's position. What we'll do is we'll load the map planes depending on the player's position. If the player's right on the corner here, we'll load these 4 segments. If the player is here, we'll load these 4, and if the player is in the middle, it will also load 4 in the middle. So I'm gonna be using 4 because my minimap planes are really huge, so I don't really need 9. So, but you can't have 9 if you create your minimap planes really small. Otherwise, you'll run into problems where you will be able to see the edges when you move at the edge of the map. And the first class, actually the third class, is going to be MapHandler. This is the main class it's going to be. Since it's I'm going to give it the same namespace, and I call it public. And since it's going to be a long class, I'm going to divide codes by regions, constants and fields, and then we need region for properties. I like doing these because I can organize my codes later. Constructors and destructors. I didn't spell it right. And region, and we need public methods, and the same for private methods, actually local methods. Alright, and then we're going to be creating a couple of constants. It's going to be a read-only asset bundle. This is the asset bundle which will be loaded later. Actually, it will not be loaded from this class, but will be loaded and sent back to this class. Private read-only map settings. Oops. As you remember earlier, this is the map settings class that we created. I don't know why it's out. That's true. We need to create map settings of our own. Okay, and I'm pretty sure it's going to complain about the thing. So let's actually give it a namespace. Put it inside our own class. Okay, and with a semicolon. Alright, map settings. Let's call it map settings. Alright, those are the two constants going to be, and then we need a way to hold all the segments that was loaded. So it's going to be another read-only map segment. It's going to be a double dimension array loaded segments equal new map segment 2, since we're gonna have 4 planes loaded at the same time. It's going to be 2 by 2, and then we need a way to we need a layer. This layer will be set as the minimap layer, so it will be only visible by the minimap camera, and then call it map layer. Oops. And let's create the constructor public. Oops. Come on, public MapHandler. Oops. And MapHandler will be passed an asset bundle. If the map handler is handling more than one asset at the same time, we can actually have this handler handle the assets instead of having to retrieve the map asset from a third-party class. But in this case, I only have one terrain, so I don't really care where the asset's coming from. And then this is going to provide the map layer. Okay. So what we're going to do is we're going to set all of them, actually bundle equal map asset, and this dot map settings equal map settings, and this dot map layer equal map layer. Okay. Alright, now what we're going to do is we're going to create some local classes, local methods to actually load all these segments depending on the player's position. So the first method, what we're going to do is to get the actual the current segment coordinate from the current player position. It's going to be it's going to return a vector2 get a segment coord for position. I'm going to create two kinds of classes. One will get the vector2 and the other will get float x and y. And this function will just simply return this dot get segment coord position dot x position dot y. Okay, so we're going to figure out what will be the segment coordinate for the position that was given. So this will actually actually clamp it between the min and max value of the actual map. First of all, let's actually do it. mathf dot clamp x comma map settings dot xmin, because it's going to be clamping in between the minimum and the maximum of the map bounds x max. Before we do that, we need an offset. Since the as you remember earlier, I mentioned the map will be offset by x half unit comma z half unit. So we need a way to we are actually centering our current map on the 0 0, but the actual map is offset by the x half unit and the z half unit. So we need a way to actually hold this offset position. So when we load it, we don't really have to care about offsetting this position by that. So right now, what we're going to do is we can actually get the create the actual offset. So, and also you probably need to place the map at a certain height. So this map offset will do that trick. So what we're going to do is we're going to actually get the map offset. Alright, so let's calculate that. This dot map offset equal new vector. Now the first thing is going to be map settings dot length. As you can remember, x half unit is going to be the length divided by 2, and the height, I'm providing a initial height 200. You can provide, this is the height the plane is going to be located after it's instantiated. And the second thing is the width divided by 2. That's the offset is going to be. The map will be offset by that position. Actually, the segments. Alright, and then actually we need a way to hold actual current map bounds. As you remember, I told you there's going to be a square wherever the player goes. There will be 4 segments within one bound. So this will hold the excuse me, that bound. So we'll hold map bounds, and we don't really need to set it right now. It will be automatically set at a later time. This dot map bounds, let's 0 all the values. Alright, this is what we need right now. So let's go back, and as you know, as I said earlier, we need to offset the map by that x amount. So this will do the trick. Instead of somebody actually have to manually provide it. Alright, and then this will be NZ. N stands for normalized, you know. I just, in case you're wondering why I called it NZ or NX. Actually, oh, that's true. It's, excuse me, it's Z. Alright, excuse me. And we're gonna have PZ, PX. Means position X. And then what I'm gonna be dividing NX by the map settings dot length, and I'm gonna cast it to an integer. Okay, what we're doing right now is by casting it to an integer, we're omitting all the floating point given out, and we're just casting it to the lowest. You can simply do mat.floor, or if you don't really want to call it a third-party function, this will do the same thing. It's basically like calling mat.floor, because we only want the digit, not the floating numbers, to actually calculate the current coordinate position for the segments. And I'm doing the same thing, NZ divided by map settings dot width. And what we're going to do is, to get the actual coordinate, we're going to multiply it by, since it's an integer, we're going to get the perfect value, px multiplied by map settings dot length. Well, alright, and as you can see, these looks exactly the same. I'm just dividing it and multiplying it. No, I'm not doing the same thing over again. I'm just casting it to an integer. This will not be the same value. In case you're wondering why I'm actually dividing and multiplying by the same number. AZ equal PZ multiplied by map settings dot width. And then we're going to return new vector. It's going to contain AX and AZ. Alright, and that is the function to get the current segment coordinate for the current position. Alright, and then the next method is going to get the actual bounds for the current position, which will be the square I mentioned earlier. So this will return a rectangle, which will be the actual bounds. Get map bounds for position, which will be in a vector 3. It will be the player's position that will be passed to us, and then we need to create same thing for float x, float z. We really don't need y, because we will be offsetting the y by 200 right there, so we really don't need y. And return this dot, get map bounds for position, position.x, position.z. Okay, so here we're going to calculate the actual the bounds using the segment coordinates. So first we're going to get the current segment seg coord for the position that was provided in the current segment x, z, and then we're going to calculate the bounds from the segments that were provided. You're right. This is just a fake bounds. Current segment coordinate dot x, current segment coordinate dot y. It's not the actual y, because vector 2 only has two values, x and y. This is not y. Think of it as z. I should have named it y, but just to avoid confusion with the actual height y, I just used it as z. All right, and then maps. Oh, it's going to be the same width as the map settings dot length and map settings dot width. Okay, so this is just a fake triangle. First fake rectangle, and we're gonna figure out where the actual position is. Bounds dot xmax. Xmax means the current x plus the width of the rectangle. If the xmax is greater than the map settings dot xmax, my bad. What we're gonna do is we're gonna reset the position. We're gonna make sure that we're subtracting the right amount. Just in case, I know in this case it's just going to be the map bounds plus x max plus the length, but I'm actually, to be safe, I'm subtracting it from the bounds. Alright, then what we're gonna do is we're gonna reset the bounds, and the x min, since we found out it's greater than x max, so we're gonna recalculate the every values to make sure it's on the x max. It's actually aligned with the edges, so that's what I basically meant. And then bounds dot x min, which will be the current bounds minus the value, and then the z dot x. So what we're basically doing is we're actually recalculating the coordinate position, but we can't just assign bounds dot x min dot minus a val. But just to be safe, I'm calling this function. You don't really have to. You can just assign this value, just in case if a value got mixed up, just to be safe. Okay, and then we're gonna I'm gonna do the same thing, and with this guy I'm gonna provide the oh my bad, bounds dot x max, oops, minus value comma z dot x, and the same thing. It's gonna recalculate the x min and the x max. And the other case is going to be, we're gonna check to see if the bounds dot y max is not the height, as I mentioned earlier. It is z max, since rect doesn't support z, so it only has two values. And if the z max is greater than map settings dot z max, we're gonna do the same thing as we did earlier. We're gonna calculate the value that we need to subtract. Bounds dot y max, again it's z max, map settings dot z max, and we're gonna do the same thing. Bounds dot y min equal this dot get segment coordinate for position. Bounds dot z min y min minus value. Actually, this, since it's z, I forgot it should be on the y. Bounds dot y max, actually y min minus val dot y. Do the same thing, and for y max, and do the same thing y max. Okay, so this is two cases, but we need also make sure it does not go below the lowest possible value. So we need an else if x less than current segment coord dot x. Just make sure that the it does not go below the lowest possible map bounds for the current position. So bounds dot x min minus map settings dot length. We're just going to subtract the length. Oops. Bounds dot x min. We're just going to offset the bounds to the left by the length and the width. Oops. Map settings dot length. You do the same thing for z. Else if z less than current segment coordinate dot y, again it's z. Alright, and then we're gonna set the same thing as we did earlier. Bounds dot y min minus equal map settings dot width. Bounds dot, we're just offsetting the bounds, and y max map setting, oops, map settings dot width. Alright, so which will give the which will set the bounds to the actual bounds, and then we can return the bounds. Alright, this will get the current bounds for the player's position for the current coordinate. Alright, then we need some method to actually load the segment. So the first method is going to be, which is going to return a game object, and this will create the segment at a certain position, vector 2 coordinate, and then game object. It will, oops, it will create the segment at the position and will return the game object. Var go, oops, equal mono behavior dot instantiate. This will instantiate the actual instance segment. Actually, this will be the segment game object. Segment as game object. This will cast it to a game object, and then we're gonna set the transform. Well, you can also set it in the instantiate, but I like setting it separately. That's just me. What we're gonna do is coordinate.x. This is what we're gonna offset. As I mentioned earlier, the map will be offset by the x half. In this case, map settings.width or length divided by 2. Map offset that we calculated earlier. Map offset. This is the height of the segment, and coordinate.y. As I mentioned earlier, this is not z. I mean, this is not y. This is a map offset dot z. And then we can assign the layer of the segment to the layer that we got earlier, map layer. So we can make sure that the segment will be only visible in the map layer, and then we can return the game object. And then we need another function to load and create. This will load the current segment, and it will create the segment at the same time. This function will be used at when you start the game, where you need to create all the segments without loading it separately. And then we're going to provide float x, float z. And this will be seg coordinate equal. We're going to get the current segment coordinate, get current, nope. And we're going to provide x and z. This will get the segment, and we're going to create segment, this dot load segment. This will we need to create this method to load segment at int segment coordinate. We're going to provide the actual segment coordinate where you need to actually load. This will look inside the asset bundle for the given coordinate. Since we did not save the position as a float, so we need to cast it back to an integer. And then we need to do the same thing, segment coordinate dot y. And we need to create that method with generator, and this will be game object. And since I know it's in a local function, it's going to be x and z. And let's load that. Return. This will load from the asset bundle. This will not load it asynchronously, but it will just load it and load. And then we need to give the name. This will be the same format that we gave earlier. And the first value, if you remember earlier, is the x, and a hyphen, and the z, and dot, and then the segment name. First, we're going to provide the x and the z, and map settings dot name. Alright, and I'm going to close that. And then we need to provide what type of asset we need to get, which is going to be a game object, and we're going to cast it as a game object. And that's it. And this will get the segment, and then we need to oops, and then we need to instantiate it, mono behavior, or this. You know, let's use game object. It's more reasonable to use game object rather than using mono behavior. And then we need to instantiate this. Let's provide segment as game object. We're going to do the same thing as we did earlier. We're going to do the Gonna offset it, and then do that, and then return game object. In this case, it's going to be X and Z. All right, and that's that. And we'll load, and we'll load over and over. Okay, and now what we need to create is the method to actually create, or when the game starts, we need a method to create all the segments. So let's create a method called prepare map at, and this will only be called when the scene or the map starts. This dot map bounds will calculate the new map bounds. This dot get map bounds for position, and this will get the position, and we're gonna set all the arrays that we created earlier. Loaded segments 0, 0, which will be the lowest left corner. New map segment, and I'm gonna set the properties. Game object equal, we're gonna load it, load and create segment at, I'm gonna provide, oops, as a matter of fact, you already calculated the bounds. Map bounds dot xmin map bounds dot zmin, ymin. Okay, and then we need to set the state to be active. So at this moment we know it's actually already created. And let's comment it. It's the bottom right. And I'm gonna copy it and paste it a couple of times. 4 times actually. Didn't want to do that. Okay. And then the next value, which is going to be, make sure you actually set the you don't actually type them wrong. If you type one value mistakenly, it's not going to load it correctly. So, and 1 0 is going to be the top. I'm actually bottom right. So which will be X max, and the other one will be 0 1, which will be the top left, and which will be Y max, and then 1 1 is the top right. So X max and Y max. Alright, then we need another method to update it periodically. This method will look to see if the player's position has been changed. If it has been changed, it will update the map to reflect the changes, and it will load the segments asynchronously. Alright, this method will be called update map at position vector 3 position. Alright, and this will create the new map bounds. This will make sure, this will check to see if the current, it will compare the current and the old map bounds, and if there's change, it will reload the appropriate segment. And this is a way to make sure that the bounds has been changed or not. If the new bounds dot xmin is less than map bounds dot xmin. If the xmin has been changed, we need to reload it. This dot loaded segments. First one we're going to load is the top right. So as the map moves to the left, this means that the player has moved to the left. So we need to replace the top right with the top left, and we need to replace the bottom right with the bottom left. So instead of calling the array over and over, which is confusing because you don't know which index corresponds to which, I'm going to create some properties to make our life easier by creating the actual corners, the 4 corners. So the first map is going to be the bottom left, which will return this dot loaded segments. The bottom left is going to be 0 0, and then I'm going to copy it a bunch of times, actually 4 times, And then the second one is going to be the bottom right, which is going to be 1, 0. And then the other one's going to be top left, which will be 0, 1, and then top right. These are just the 4 corners of the current loaded segments. So it will be 1 and 1. Now all you have to do is just reset everything. And then, so we need to replace the top right with the top left. We create it. This is why we created that function. So this will not destroy the old segment, the old game object, but it will change it, replace it to the new one. This will save us from recreating the game object over again. So we're going to replace that with top left, and then we're going to replace the bottom right with the bottom left. And then we're gonna reset the top left. The top left has already been replaced, so we need to reset it. This will destroy the top left game object. Oh, just call it reset. This dot, bottom right, bottom left, dot reset. Actually, I take back what I said. When you call replace, it will destroy the old game object. When you call reset, it will not destroy, but will, because the top left's game object will be in the top right's game object. But the top right game object will already be destroyed. So calling reset will not do it. We don't have to destroy it again after we replace it. If it gets confusing, just take a moment to think about it, and I'm pretty sure you'll get it. Changed equal false. Actually, true. Alright, so we'll notify that there has been a change, and we're going to do the same thing with the ymin, actually zmin. If new bounds dot ymin is less than map bounds dot ymin. If the z has been changed, that means the player came downwards. If that happened, what we're going to do is we're going to change the top left with the top right, and we're going to replace the bottom left with the bottom right. Actually, I got it reversed. Actually, we're going to replace the top left with the bottom left, and we're going to replace the top right with the bottom right. Yep. And so let's do top left dot replace with bottom left. It's just like offsetting the map top right, but in this case we got 4 variables to take into consideration. Replace with bottom right, and then we're going to reset bottom left and bottom right. This dot bottom right dot reset, and then make sure the change has been taken place. Alright, and then we need a way to monitor when the player moves to the right. So else if, because since moving to the left and moving to the right doesn't happen at the same time, I'm going to do else if. New map bounds dot xmax if the xmax is greater than map bounds dot xmax. We're going to set it. So in this case, we're going to set the top left with top right and bottom left with bottom right, and then we can reset the other two. This dot top left dot replace with the top right, and we're gonna replace the bottom left with the bottom right, and then we're gonna reset those two, top right dot reset, and then we're gonna do bottom right dot reset, and we're gonna make sure that there's a change has been taking place. We're gonna do the same thing here. You know what? Copying and pasting. For this one, I'm not gonna copy and paste because they're all different, and there is more likely I'll make a mistake. So don't really want that. Ymax. Same thing if the player moves upwards. same thing, ymax. And in this case, I guess you figured it out. We're gonna replace the bottom left with the top left and the bottom right with the top right, and then we're gonna reset the other two. Just dot bottom left replace with the top left. This dot bottom right replace top right. Okay, and then we're gonna reset the other two. Top left dot reset, and this dot top right, oops, dot reset, and then you're gonna set the changed equal true. All right, that's long coding. What is this? Okay, that's true. Replace. Okay, and then we need to make sure if there's a change, we need to recalculate whatever change. We're gonna reset all the game object and all that. That's dot map bounds. We're gonna set the map bounds to the new map bounds. So that will be set. Make sure you do that. If you don't do that, the map bounds will not update, and it will end up redrawing the same game object over and over and over whenever the function gets called. And then we're gonna create another function which will handle the segment at, which will check to see if the segment is destroyed or if the segment is alive or loading. Depending on the state, it will load or pause the loading, and this will do that. And this will bottom left. Since the bottom left is going to be located on xmin map bounds dot ymin, again it's zmin, and then the same thing we need to do 4 more, and the other one's going to be the bottom right, which will be located at xmax and ymin, and then the top left located xmin ymax zmax, of course, and then top right it's going to be xmax ymax. Okay, so this function will handle the map depending on the state. I'm gonna create that. I don't want that. Alright, this will be X and Z, and this will be segment. Alright, we'll check to see if the current state of the segment is destroyed. If it's destroyed, it needs to load it. So this dot load. You know what? Excuse me. You know what? I'm gonna have the main method, whatever class which calls this method to load the map for us, instead of me calling the asynchronous method. So I'm gonna create an interface which will be iMapLoader, because I'm pretty sure I'm gonna create a class which is a MongoDB to pass to this method, because I don't want this class to have access to a MongoDB class, but I want this to be treated as a separate class, iMapLoader. Alright, so now we need to change the namespace to same one, Minimap, my Minimap, and we don't need any of these things, and then call this public, and it's going to be an interface, and the method will be void start is sync async method enumerator, since this will be called inside a coroutine. Enumerator. I'm calling this as a enumerator. You can provide the method name, but that includes reflection. The Unity has to look up the method by reflection, so that's why I'm just calling it as enumerator. And we need to pass this interface to our class, and we need a way to reference this class. MapHandler, call it MapHandler, and MapHandler, actually loader, my bad, and then call it MapLoader, This will be passed to us from the method in which we will be created. Map loader equal map, come on, map loader. Okay, now we're going to use this class to queue a method to be called asynchronously, which will be the method to actually load the segment. So this dot map loader dot start async method add, and then we will be creating a method called wait until segment load at, and then we're going to be providing the name of the segment, actually the actual segment, and then the coordinate in which to load the and then make sure you import system dot collections. Okay, so what we're gonna do, we're gonna reset the state of the segment to be loading. The reason I'm doing that is it's already reset to destroyed. If you don't set it to loading, whenever this function will be called again, we'll queue the loading over and over and over again. To avoid that, I'm setting it to loading. And then we're gonna calculate the coordinate for the current segment. Get segment coordinate for position x comma z, and then async request this. Oh, we'll explain this in a moment. Load segment async at this will not load the segment instantly as like this method. This loads it instantly, but this method will make sure that the segment will be loaded asynchronously in another thread. The reason is we don't want any lag spikes in between loading times, because the loading the segment is going to take time. So if you have a bigger segment, it's going to take a long time. So we don't want any delay in the playtime. That's why I'm calling this synchronously, since the method will be called during playtime. And we need to actually pass the actual x and segment coordinate x excuse me, and then we'll do the same thing, and this will make sure that it will be called at that time, and we'll be group everything with all the other method. And since this will be an asset bundle request, whenever you load asynchronously, it will actually create a asset bundle request from an asset bundle. And then we're going to call it bundle.load asynchronously. We're going to provide the name, and just like the same we did earlier, I just copied and pasted it. We provide the type of game object, so it will be a prefab, and that's that. Let's go back and then let's finish this class. Oh, will be, has to be y. Okay, and then let's return, actually yield return the async request. What happens is you can't return any async request to an enumerator. What happens is the coroutine waits until the async request returns done. As you can see, async request done. There's this property which will return true if the asset bundle finished loading. So it will return. It will go back to the next line when it's done. So then we can assign. At this point, the segment is loaded. It's ready to be instantiated. So we're gonna create this segment, and we're gonna provide the actual coordinate, segment coordinate position, and we're gonna get the actual game object async request dot asset. This is the asset that was loaded inside the asset bundle, and then we're gonna cast it as a game object. Alright, and then we're gonna reset the state, segment dot state equal active. That's it. That's all we need. Now all we have to do is call these methods from another class to load them. first, I'm going to create some public methods. Let's finish this class out before we move on to the next one. First, we need a method, public method, to actually start this map loader. So I'm going to call this start vector3 position. And what this will do is this will prepare the map at that position. This will load all the segments, the current coordinate. So this will not load it asynchronously. It will load it in one go. And then this will be called periodically. Update map. And then I'm going to provide a position. S-I-T-I-O-N. And this will call, same thing, update map at position. And we need another method which will unload the method, the class. This will only bundle dot unload. This will load the bundle. It asks for do you want to unload all loaded objects. This will clear all the loaded game objects in the scene, but including the instantiated ones. So, and then just gonna do that. Start, since it's a public method, I like to give a summary of a public method that I create. Starts the map and updates the map. Make sure this function is not called every frame. Since we have to do calculations, you have to call it periodically. Call this and unloads the map. Alright, that's all for this class, and in the next video we will be creating the map, the class, the Minimap behavior class to actually load everything. So see you next time.